Perfect. So with this, I heartily welcome everyone that is here in that session that took the long journey to arrive here and the long distance. This is today a collaboration between Meetup Stuttgart and Meetup Constance. So we put both together. At least we got around 11 people here in that session. A little bit weird, but not unexpected because of the RSVPs that we had before. It was much more. But anyway, today's session is really a big cool story about workloads. So Stefan is here with me together as co-organizer for Azure Meetup and Constance. And he will bring his best to explain you a little bit about that story. So I think that you are here because out of curiosity about this topic. Stefan is an Azure MVP, so he was announced as MVP for just a couple of weeks ago. It's quite an honor to have him as a speaker with his title now in his first, let's say, official game here. And I would say I just shut up and just hand over to Stefan so that he can introduce himself and his topic. And we'll go.
Yeah, thank you, Thomas. Yes, thanks for the quick introduction. And thanks for having me today. With this topic, the secure cloud workloads, so a developer's guide to cloud network security. So how we worked out this topic, more or less it came from customer presentations. Yeah, there are common questions which happened quite often during a project. And so we thought, okay, let's do a presentation or a talk out of it to address all the common questions regarding network security, especially when it comes for development, because quite often we heard the same questions over and over again. And so we made a choice to collect all the information and brought it into this presentation. So also, some developers, they say, development is quite nice, but when they see the first IP address, more or less the day is done. So that's the reason why sometimes our developers are scared of or confused of network infrastructure and how it works. And so they say, just give me an Azure subscription and I can do the rest on my own. But this is, as we know, in an enterprise environment, not a really valuable approach. So we need a little bit more structure. And for the developers, we need we want to show what they have to take care of, what they have to focus on, and how to bring infrastructure to the developers as well. And so that's the reason why we made this kind of presentation. Yeah. As an introduction, how a cloud project normally starts. We know normally an enterprise goes to a cloud transformation journey or wants to start a cloud transformation journey. And we talk a lot in the beginning about strategy, governance, but also application modernization, application migration. And so, but what I also noticed is that the development teams quite often they have left behind. So quite often they are not a part of the strategy, and no one talks to each other. Yeah, we have a development team, but they are not part of the project yet. But probably later. But that shouldn't be that shouldn't be an issue. And because normally development teams should be on the project right from the beginning, and that's also the reason why how the project runs also like this. Not only for legacy software, but also sometimes for new software, because they don't have proper governance set up, no cost control, no cloud landing. So nobody knows really who has to lead an infrastructure, and somehow is somebody working on the project, but it's not really well coordinated, and they are fighting more with the software than with innovations, and have to then to bring the application modernization forward. And to avoid that, we want to have a look on the following, I would say, content. First of all, we want to have a look at the prerequisites. So what we really need to have a focus on cloud network security from a development perspective. Also that bridge the gap a little bit to the first three Azure Landing Zone series we did here in the Azure Meetup, but also have a look on Azure Network Services, have a look on Azure Virtual Networks especially, so how they are configured, what's the right way to set that up. Talk a little bit about Azure Service Endpoints and what is the difference between service endpoints and Azure Private Endpoints. And we talk about two general Azure security services as well, and also then summarize the whole thing as key takeaways. And we will have a look on the summary. So what are really the essentials about it, and which questions you have to address in future project as a developer to make sure that everything's correct and set up correct. Yeah, what are the prerequisites? Yeah, which requirements must be fulfilled before we start to bring an application workload to the cloud, no matter if it's a migration or modernization. So as we talked in previous sessions here in the Azure Meetup, first of all, we need a cloud strategy. Yeah, we need to know why we should go to a cloud, what's the destination, what is the business justification, and what we want to really achieve. Cloud itself is not, I would say, self project on its own. You need a reason why you want to go to the cloud and why you're focusing on it. And if you define the cloud strategy and what you really want to achieve, it also makes sense to put in the beginning, put a cloud national governance concept in place. So define your concept. So how do you do cost management? How you set up your Azure hierarchy before the management groups, naming conventions, and so on. Because quite often, for example, I see that the naming convention is often not there. Resources look like a bloody mess. So it makes sense to talk about these topics, also about tags and log strategy. So which resources must be protected, which must be tagged so you can have also proper cost management. Role-based access control, super important that you have in place also for your resources and also for your future workloads, and also Azure policies here. So this is normally what we also did in the beginning of the Azure Landing Zone series to talk about governance. The second part is then before we're going to start the first shifting or more programming the first workload in the cloud is we need to have some kind of core infrastructure. That means also general design of a landing zone. So where do we place our applications? How the network architecture look like? What are hybrid connections? For example, if we have already existing data centers on premise, and how do we secure the traffic? Are we using an Azure firewall, or do we use an Azure NVA, like, for example, FortiGate or something else? And how do we do logging and monitoring, for example? And we have also several more topics like backup and how we handle compute instances and so on. Yeah, so this is part mostly of the infrastructure team, so they have to define it and have to figure out, okay, how we're going to do the hybrid connection to the cloud. And what is also quite important is we had it, I think, in the third series, is the topic cloud automation. So quite often I see it customers, they do click cloud. So that means they're using the mouse, adding or managing, provisioning cloud resources. But I highly recommend using infrastructure as code, no matter what you use, if it's Azure Bicep or if it's Terraform or Pulumi or whatever. Make sure that you have some kind of central module library in place, and you're not clicking your infrastructure instead of programming reusable modules, which then also will be deployed using a CI/CD pipeline, which is, in my opinion, is super important, because only then you can provide a full end-to-end automation process. Yeah, and of course, every topic must be also security related, just to make sure that we have the right approach and also follow the governance and compliance principles of the enterprise. Otherwise, we could easily get breached or having data loss or whatever. So why are we talking about network security, especially today? Yeah, I mean, what is the presentation about is that we have some kind of best practices regarding network security. And this is also covering a lot of stuff from customer projects. So if we talk about the content, we'll have a look about best practices and what we really want to enable that best practices and what happens if we do not follow the best practices. Because quite often I saw a customer, they were struggling, especially when they started on their own without any considerations of, for example, the Microsoft Cloud Adoption Framework, which is totally essential to me, that that you normally succeed and bring a cloud project also to the goal or to the destination you want, which you have to define in the strategy. And also, what we have to consider is the well-architected framework from Microsoft. Both are super helpful if you want to lift and shift, or even if you modernize applications to the cloud. Have a look at that and also go through all the details. And a lot of details are also covered in this presentation as well. Yeah. So as a big recommendation, stay up to date. Don't get left behind. Yeah, have a look on the Microsoft pages, and also because they do a lot of recommendations, which are really essential to the success of a cloud project. So when it comes to network security, there are a lot of services. I just did a quick screenshot. There are only some. What we are focusing on is today the network security, networking services, especially where we'll have a look at. A little bit, we are working with the storage account, but only to illustrate how we secure services like storage account, SQL databases, or Key Vault, or whatever. So the services pretty much behave always the same, but we need to configure the right way so to make sure that all the network services are really secure. So there are a bunch of services, as you see here. We are focusing mostly on the connectivity services, yeah, to connect from on-premise services or connect to Azure services in general, and also to protect your cloud workloads. Yeah. So we're gonna start at the virtual network and also have a look on service endpoints and also private endpoints and so on, which is also covered in the first two sections, I would say. Yeah. So resources must not only be protected from the Azure side, but also from the on-premise side, because quite often we have hybrid scenarios in an environment, because there are already existing data centers, and sometimes you want to use, for example, an Azure SQL database from an on-premise side or from on-premise region, and you need to make sure that the connection is secure, and nothing happens during your data access. So the first thing, which is pretty basic, but also some guys told me it's fundamental to understand how an Azure virtual network works and why we set it up in a certain kind of way. So when we go through it, I go through the slides, but also to the Azure portal, and also I have some architecture chart where we go a little bit more in detail. So the first concept we have to understand if it comes to a virtual network is the hub and spoke architecture. For you as a developer, for example, hub and spoke is like a Ferris wheel. Yeah, you have in the middle, you have the hub, which is that are carrying elements which are essential so that the whole the ferry wheel is working. And on the outside, you have certain kind of spoke. So each part is a spoke. So this is a spoke of an application. This is another application. This is a web application. This is a CRM application, and so on. The same is like with the network. So you have a hub virtual network, and a hub contains all shared Azure services. Yeah. So it makes, of course, sense. For example, if you have a more or less legacy application which speaks still LDAP or LDAP-S, they do have domain controllers, and the domain controllers, of course, are placed in the virtual hub because that are shared services. Because probably another application like this one here can also use LDAP-S authentication, and then it makes sense that your domain controller are in the middle of your hub. Or Azure Firewall, for example, traffic management, or the gateway to your on-premise data center. It totally makes sense that we have all the shared services in the hub, and we have on the outside around the hub, which are connected, like you see, like a star or snowflake symbol. The spokes are connected to your hub. For example, if you have an application workload, you have a separated spoke. You have the next application workload also with a separate spoke. So these ones are more or less isolated from each other. Yeah. So this is the first concept we have to understand. If we look on a high-level architecture chart and we will go more into detail. As you see here, this is the spoke. Yeah, we have shared services like, for example, I mentioned Azure Firewall, or we have the VPN connection, which is also not necessary for other applications as well. And we have also some kind of DNS stuff and so on. And then you see the spokes. You see a spoke here, which is some kind of web application. We have the next spoke, which is here, which is probably some kind of CRM application, whatever. And we have the next spoke and the next spoke. And so you can set up more or less your hub and spoke network as also, which is really necessary, which will see in the next slide, that you design your network before we start for your enterprise in a proper way. So all this, so a landing zone, if an infrastructure guy talks about landing zone, this is what we are talking about, this hub and spoke technology. So the on-premise data center is connected to the hub, and outside we have our application. If you have to program a new application, you will get a new spoke. That's more or less what it's all about. So when we talk about Azure VNets, I heard it quite often. Yeah, we need more VNets because then we have more security. No, that's not really the case. In Azure, a virtual network is more a logical separation. So they are not tied any security features to a virtual network. Yeah, so you cannot assign a network security group or a route table to it. That doesn't make sense. So it's only more or less a logical separation. But within the virtual network, that's the blue dotted line here. You have subnets. Yeah, this is the gray dotted line. Yeah, and in the subnets you can isolate your traffic using either, for example, NSGs that are network security group where you can filter traffic. So you say, okay, what is my source address? What is my protocol? So TCP, UDP. What is my port and what is my destination? We come to that later. And or you can also use an Azure Firewall or an NVA. Azure Firewall is quite comfortable because it's a platform as service. It scales automatically. On the other side, you can also use other stuff like Fortinet or Barracuda or whatever. Yeah, so it's also possible. And we have support for IP address ranges. So you see here the CIDR blocks, which we, for example, 10.00/16, which means, okay, we have, I think, about 65,000 host addresses in here because /16 is quite a big one. And it shouldn't be overlapping. So what you shouldn't do is, for example, in this chart, having the same IP address here, like address range here, like on this one here. So each, and also not the same like on the hub. So it must be unique, and you should be able, or you need to know which IP address range I have for my VNet. It supports static and automatic, static and dynamic IP addresses, and these DHCPs out of the box. So we don't have to think about DHCPs. Azure will do that for us if we have dynamic IP addresses. And also on the virtual network, we have DNS support. So if we have to configure a virtual network, it also makes sense, as you see here, we have here DNS servers configuration. So we have to say, okay, where's my DNS server for name resolution? Because that's quite essential. Quite often I have discussions about DNS. Meanwhile, a colleague says if we have a bug or an error in the infrastructure, she says it's always DNS. So think about this topic and talk to your infrastructure guys about DNS and how they're going to do the resolution of DNS. And of course, we have hybrid connectivity support for for VPN connections, either side to side or point to side, but we also can have express routes. Yeah. So what we cannot do, we cannot span a virtual network over different subscriptions. So because if we do it with different subscriptions, we have to take care of something special, and this is called Azure Virtual Network Peering. As you see here, we have the hub and we have the spoke. And the hub, for example, is a totally different subscription because that's managed by our infrastructure team. But then we have here applications, and probably this is managed by the application team on another different subscription. Now we have to bring them somehow together, and that means we can do a virtual network peering between the two networks. That means, okay, the infrastructure team will peer from the hub to the spoke, and the developers will peer from the spoke to the hub, and then you have a connected network, more or less. Yeah, quite straightforward. So that are the lines between, I would say, the spoke and the hub. So to make sure that all the VNets are connected to the hub. So if we want to connect two VNets, we can also connect it to the same or to another region. And what does a peering mean? It means that the traffic flows through the Azure backbone. So from one VNet to the other, we have peering. We can peer what A to B, and normally we could peer B to C. What you shouldn't do is do not establish a connection, for example, from A to C. That's the same if I would do peer this spoke and this spoke. This shouldn't be done. Because if we, for example, if we need a connection between, for whatever reason, this from this spoke to this spoke here, the traffic goes from the spoke to the hub and then to this spoke. Yeah. Think about the Ferris wheel. We do not go directly from one car to another. It's more going from one cabin to another. We go from one cabin to the middle, from the middle to the cabin. Yeah. So that's why we call it hub and spoke network. Otherwise, we will not be able to manage the traffic with the firewall here in the middle of the hub. So we can peer two or more virtual networks. Also, make sure that the virtual networks and the IP address range don't overlap. It's also why I'm a big fan of before we start, let's talk to the infrastructure team, which IP address ranges or CIDR blocks are still available. Yeah. So normally they have lists before we start. Say, okay, and then they will talk, okay, how many hosts do you really need? You see the yellow marked line, and at the moment we have the 10, 104/0//26. That means 62 hosts fit in. Yeah, you can also size it smaller if you don't need 62 hosts. That's quite a lot. So if you see here, if we do a /26 subnet, you see the number of possible subnets are 16. If we count here, there are 16 subnets. If we do it smaller, then we only 31 hosts will fit in, but then we have 32 subnets. So that depends on your workload. How big is your workload? How many machines? How many private endpoints you need? If you have, for example, I don't know, SAP system or a bigger application, you need quite more hosts. If you have a small application, probably also you can work with a /28, which is totally fine. Yeah. But make sure you do a proper planning. And what I like to do quite often is this kind of subnet calculator. Zoom a little bit in. So you can subdivide your IP address range and say, okay, probably /26, or that's quite a lot. Let's do it for a small application or POC. Okay, we can get along with a /28. Yeah. So do not use more, or don't ask for more addresses if you don't really need them, because we had also big car manufacturer, they run out of private IP address ranges because every department had a /16, and yeah, according to the motto, okay, what costs the world? Let's do a switch /16, then we are safe. But in a /16, as you can see here, 65,000 hosts would fit in. That's quite a big application. So first of all, we think about how we design or size the network for dev, for test, but also for the prod system, right? Before we're going to start. What is also quite often, we have this kind of zero trust network. That's more, I mean, what does that mean? We have to design our hub and spoke in a way that we have, okay, make sure that we have the right sizes and also that the subnets and so on are protected. So the first topic is verify explicitly. So the user has to authenticate, or the service principal has to authenticate and to authorize. We need to know who that is and if they have permissions on the resource. And we have also the least privileged approach. Remember, in the beginning we talked about, we had a quick chat about rule-based access control. Don't give all to your users global admin rights. Yeah? That doesn't make sense. We only give them the rights, what they really need, and assume you get breached. So that makes sure that you have, instead of one big subnet where everything is in, let's subdivide the workloads into smaller subnets and smaller pieces. So to make sure if you have a breach, only a few machines are affected, and you can isolate them, throw them away, recreate them, and protect them. Yeah. So this is more or less kind of strategy, which is really super helpful. And yeah, make sure that, because quite often I saw monster subnets, because I had quite often had to do a Azure review and have a look at already existing environments. And sometimes I was not really happy what I was seeing there, because they had really connected with everything. And also the Azure firewall in the which should control the traffic right here in the middle has had any rules on it. Yeah, that doesn't make sense, because we need to also think, okay, which system has to communicate with which subnet? For example, is this virtual machine allowed to talk to the DNS, or is this virtual machine allowed to talk to this network interface card? Yeah, because we need proper rules in place, and we also have as a developer, we have to think about, okay, what ports and protocols do I really need to make sure that my application runs the right way, yeah, and not that the half of the stuff is blocked or suddenly the application stops. To control the traffic, I mean, we can talk about network security groups. We can have a look on this side. We can have a look at this in the portal as well. So first of all, we have here the network security group. A network security group is pretty straightforward to control or manage traffic. I added here some net NSGs already using infrastructure as code, and we can have a look. And it's we have two kind of rule sets on an NSG. We have inbound rules and we have outbound rules. So as you see, this symbol here is an NSG, and we have already rules on it. Yeah, so it more or less, this NSG protects the whole subnet, which we see here, and this one protects the next subnet. Yeah, so we can more or less control what goes in and what goes out using here the inbound and outbound rules. NSGs are for free. They do not cost extra, no matter how many traffic you send through it. And it supports or enables subnet segmentation scenarios. So more or less, you can isolate your subnets from each other. So you can separate the file subnet, for example, from the storage subnet, from the front end subnet. Yeah, you can, using NSG is a pretty basic Azure resource you can use for network separation. And you can have rules, two kind of rules, allow rules or deny rules. Yeah, as we see here, there are already rules on it. You see the green ones are the allow rules, the red ones are the deny rules. The ones larger than 65,000 you cannot delete. So these ones are more or less Azure default rules and restrict the traffic. So you can restrict the traffic to external or inbound traffic from external, inbound traffic from internal. and the same stuff also for the outbound traffic. So if we have a look at the inbound traffic, and for example, we can create a new rule, we can say, okay, what is the source? Let's have a look at the outbound stuff. What is the source? I mean, any source in this virtual network should be able, for example, to talk to a storage account. So that means we can do the service tag, search for storage account, storage. You can see here storage account, but we want to limit it down to a storage account in North Europe, for example, and say, okay, which port, for example, 443, which is HTTPS, TCP, give the right priority. So the one which is 100 is first, then you have 110, 120. So you can, the 100 will override the 110. So you have some kind of order, and then more or less you can add it, and a rule will be added to your NSG. I highly recommend using infrastructure as code for management, because you can get lost quite easily if your environment starts growing, and then suddenly you don't know, was it inbound, outbound, and where, and subnet, and then it's getting quite complicated, because if the traffic gets out here and wants to go in here, if you forget the inbound role here, it will be blocked. Yeah. So it makes sense to use infrastructure as code, and also you can force rules with deploy if not exists policies. Yeah. So the only downside on NSGs are what you see here is we cannot say, hey, please allow the traffic wildcard.microsoft.com. So URL or full qualified domain names are not supported. It's only this 5-tuple rule set here, which then, I mean, you can allow a certain kind of IP addresses or service tags or application security groups, which are also Azure related, and that's it. So URLs are not supported. It's also highly recommended, what we did in the previous rule we created, to use the service tags. Service tags are more or less pre-configured IP address ranges, which you can see here. Service tags, there are different kind of service tags. For example, if you want to need access to an API management, type API management, and you see you can allow the traffic to an API management in more or less each region, doesn't matter where, or you can also allow it in general. This is super helpful. And you can also, it starts with 100, and you have a maximum of until the end is 4,096. Yeah, so you don't have rules up to 65,000. It's only allowed to from 100 to 4,096. And you can assign your NSG to either a subnet, like we did here on the on a subnet, or you can also assign it to a network interface card. My recommendation is don't make it too complicated. If you assign it to both, sometimes you have double the rules and also double the administration. The administration pain, which is also means you troubleshooting is not really or can get quite often complicated. Yeah. So that are the NSGs we can have a look at. You can do the same stuff, only more more effective with Azure firewall rules. So that means also you can handle traffic in the firewall, but this is a topic which is quite. You can do a whole session about an Azure firewall and how it works. You can also get access with rule collection groups to, that each department can set up their own firewall rules, which is also a little bit kind of risky, I would say. Normally, the Azure firewall is handled by the infrastructure team, and you as a developer talk to the infrastructure team what kind of rules need to be opened. So, for example, to make sure, you can talk for example, the web front end can talk to the storage subnet or to the file subnet. To make a clear plan how the traffic works. When we have a look at the traffic, by the way, this is a good point. We can also have a look more in detail in the architecture chart. You can see here, for example, that's the on-premise network, which we already have. Normally, an enterprise has an already existing data center. In this example, we have an on-premise data center in Stuttgart, which already exists. And now the company decides, hey, let's go to the cloud. Of course, somehow the client networks or the servers need to communicate to Azure resources. Yeah. And the most secure way is to handle it either as establish a hybrid connection using an express route, as mentioned in the beginning, or a VPN connection. So don't send your data over the internet unencrypted. Yeah, it's from security perspective, it's quite often it's critical, and it also doesn't make sense. The normal way is to establish a VPN connection, or later on also to express route, so that the connection terminates right here, and from there you can have access to more or less all the resources in your hub, in your spoke, no matter what, and make sure that you have the right Azure firewall stuff in, or the firewall rules in place. So make sure that the on-premise traffic is also allowed, that, for example, as application server can communicate over the Azure firewall, over the VPN connection, run through the firewall, and then get access, for example, to this machine or to a network interface card. Yeah, that's a normal process. Yeah, don't send it over the internet. Let's jump back to the presentation. And we also have to make sure that service endpoints are secure, and that are service endpoints are a method to provide secure and a direct connectivity to an Azure resource. Yeah. So service endpoint, when it comes to service endpoint, what is that exactly? I mean, I quite often with customers discussions say, yeah, everything needs to be secure, and how could it be that Azure services are publicly available? Of course, it's publicly available because we talk about public cloud. So and we have, of course, public internet, public interfaces also on Azure. So if we have a look on the Azure IP address ranges, they are listed. You can download the whole file and have a look at it. Yeah. So all the public internet. So we have a lot of public endpoints on Azure, which are listed, for example, here. And if we see, okay, we have action groups, and the action groups have a bunch of public interfaces. So that's also the reason why we have to protect our services against access from third parties, or access which shouldn't be allowed. And that's the reason why we have to secure our services the right way from unallowed public access, for example, but also internal access. So normally it makes sense to fully remove public internet access from the service, only to allow the VNets we had before, or the subnets that we have access from there, but not from the public internet for security reasons. So we have to provide a secure and direct connectivity to the Azure services. And also we enable private IP addresses in the virtual network to reach the endpoint. Yeah. So let's have a look how that works. On an architecture chart, for example, if you want to have a storage account and wants to get in the virtual machine right here, wants to get access to this storage account, probably it makes sense to configure a service endpoint in the beginning. Yeah. So that means each resource within this subnet can get access to the storage account, because then the traffic runs through the Azure backbone, not through the public internet. I'm going to give you an example in the Azure portal. In the Azure portal, I configured a storage account, which is that here. And as you see, the storage account and any other service pretty much the same. If you go to an Azure SQL database or to a Key Vault, there's also this kind of networking section right here. And if you see here, it's called public networking access, and there's enabled from all network is selected. And all networks mean all networks, even public internet now. You can access the storage account theoretically from using the public IP addresses, I just showed you here because there's also, if we type storage, you see even a storage account has plenty of, make it bigger, has plenty of public IP addresses in Azure. So you can attack these kind of endpoints. So in general, we don't like this setting, yeah, because access from all networks is not best. I would say, and then we talked about service endpoint. If you want to select service endpoint, okay, let's hit this button. Now we have the option to select a virtual network and say, okay, I want to add a virtual network. We have an existing virtual network, like for example, we have here a company called PrettyX, and we have a spoke. And like on this architecture chart, now I want to give the spoke or the subnet PrettyX here access to the storage account. So how are we going to do that? We select the virtual network, say, yeah, that's my virtual network. I want to configure the service endpoint, and then I can select the subnet I want to give access to. So I select this kind of storage subnet, and then it tells me, okay, you do not have enabled service endpoints. Yeah, for example, for Microsoft storage. Okay, then we have to say, okay, probably we missed one step, because what we have to do is to get access from this machine to a storage account, we have to give the subnet the permission, okay, you are allowed to get access to a storage account, because otherwise you can't more or less connect every storage account to your subnet, which is also security reason or security issue. That means, okay, let's go to the subnet, to the virtual network first. Go to the spoke, select your subnet, and say to the storage account, hey, it makes sense that you are allowed to use service endpoints. And then I said, okay, you should be allowed to configure or to connect to a storage account. Okay, let's save that. While it's saving, okay, done. We go back to the storage account. Now our network has permission to access a storage account, but we still have to do something on the storage account, which is we set enable from all networks and say, okay, select now the network. We want to select the spoke, want to select the subnet, and now we can enable it. Of course, it can take up to 15 minutes. Now we are a little bit faster, but now it's, as you see, the selected networks with service endpoints is now completed. Yeah. So what we did now, we configured a service endpoint, and of course we have to edit and we have to save it. Okay. What we did now is we gave the storage subnet access to our storage account, and you see from public internet, it's not allowed anymore to access this storage account. I think, okay, probably there could be an issue to say, okay, for my client address, I still want to get access. And you see here, that's my public IP address. And as a workaround, I can say add my client IP to this kind of range. And so still public access would be allowed, but only for my client IP address. We can do that, but it's not mandatory. Yeah. So I mean, this configuration means that we are able to access from this virtual net or from this storage subnet to the storage account and access it through the Azure backbone. So the traffic doesn't run over the internet anymore. Yeah? So this storage account is now more or less secure. If you have questions, let me know. Yeah, we can stop anytime and ask and answer questions. And what's also happened in the background, but it's only as a side note. If we configure service endpoints, it puts another route on our route table, which routes the traffic directly to virtual network service endpoints. So this is managed more or less by Microsoft. So we have now an optimized route over the Azure backbone, not on the internet or over the internet anymore, if we enable this kind of setting. I put the screenshot in here. Yeah. So the goal was to secure your critical Azure services, like with the storage account, using a service endpoint. So what are the benefits of service endpoints? Yeah, we have no extra costs. That's the good thing. No matter how many data you send through your service endpoint, it doesn't cost any extra. Yeah, we have improved security and we have optimized our routing because the traffic is not running over the internet anymore. It stays in the Azure data center. And it's simple to set up. Also switch from public IPv4 to private IP addresses. As we said, we can now access here with using the full qualified domain name of the storage account to get directly access to this kind of to the service account. And yeah, we have the DNS entries for the DNS entries for the Azure Service account remains the same, which means we have endpoints for a storage account. Yeah, you can see that here there are plenty of service endpoints. Like for example, this one, it stays the same. You see, it hasn't changed. Yeah. So if we use this kind of full qualified domain name, we can access the storage account without any issues. Yeah. We come later to the private endpoint. There it will be a little bit different. And what we also can do, we can use the NSGs we had before to block the outbound traffic, for example, using service tags. Yeah. So because then we can say, okay, the traffic is denied or is blocked, then you cannot even reach the storage account. We have even some limitations on service endpoints because it's not available for, it's not reliable. It's only available for certain kind of services, not for all. We have here a list where it's listed on the Microsoft Docs. I will upload the slides later on to my GitHub account so you can actually see it. It cannot be used from an for traffic from on-premise. So that means we have access from the storage subnet right here to the storage account. But what is not possible to connect, for example, from an on-premise application server over the VPN connection, over the peering to this subnet and then to the storage account. This is not doable. Service endpoints are limited to Azure subnets. That's it. Yeah. If we want to connect from on-premise, we use something else, which I will show you later. Okay. But keep in mind, if you need on-premise access to, then service endpoints are not the best to connect to the service. So, we can still allow a client IP address from public network, as we saw in the Azure portal. And yeah, Azure service using Azure public IP address will stop working. Yeah, as long as we keep our settings like we had here in the networking section. If this one is deselected and this one is selected, all is fine, and the public traffic will be blocked from the public internet. Yeah, and we also have a list of allowed trusted services which you can enable. So that's quite easy because here you have a allowed list, which is whitelisting from which, if you select that, it's allowed by default. So you can read through the Microsoft Docs which kind of services by default have access to a storage account if you set this kind of checkbox. Yeah, that's totally fine. It makes it way easy to configure Azure services to give them access to the storage account. All right, let's go to the next questions until now, or quite clear? All right. Then we go to the next point, which I already told you. We have also can use private endpoints. So private endpoints are working a little bit different in service endpoints, for example. Because then it's not giving access to the subnet, but it places a NIC using a private IP address in your virtual network or in your subnet, which you can see here in this example. If you have a storage account and a private endpoint is nothing else than a normal network interface card with an IP address. In this example, 10.1.1.5. So if you use a virtual machine and said, hey, go to the 10.1.1.5, it will reach the storage account. Yeah. So more or less your service or your storage account behaves like a normal, like a normal virtual machine within your network. Yeah. The good thing is you can use for example, get access to the to this kind of network interface card also from on-premise. So if you ping, for example, or if you access from on-premise the 10.1.1.5, it will go over the VPN connection or express route to your network interface card and then get access to your storage account. Totally doable. Yeah. The thing is, each traffic that goes over the network interface card costs extra. So if you put a lot or a huge amount of data over it, as you see here in this example, if you put 1 terabyte data on the storage account and you put and you pull the 1 terabyte of data out of the storage account, you have to spend $26. Yeah, that's quite so. If you have, for example, a huge profiles or huge data, a huge amount of data, think about if a private endpoint is really, really needed, because quite often it happens that it really is expensive kind of protection of your service, no matter if it is a storage account like in this example, or a SQL database or a Key Vault or whatever. Yeah, we have you name it. So we can have a look at that. So like, for example, in this storage account here, we have another storage account, which is called 0816 instead 0815. And what we have to do is we have to place a network interface card in the subnet, and this network interface card is a read-only interface card. So if you secure your storage account with a private endpoint, you cannot change things here because it's read-only managed by Microsoft. Yeah? The only thing you can manage is the private endpoint itself, but not the network interface card. Yeah? So let's have a look how that works. We can also go to another to a new storage account, and as we said, there's another section right here which is private endpoint connection. Yeah? So now let's add a private endpoint. I would say, and you see that's the name of the network interface card, which will be created in West Europe. Go to next. What we have to select here for the storage account, do we want a private endpoint for blob, table, queue, file, web, whatever, DFS? In our case, let's keep it simple. We do one for file, so that to make sure that we can access the file service of the storage account. And now we say, okay, in which network we want to place our network interface card, and then say, okay, not in the hub, but in the spoke, because we want to make sure that our storage, for example, we have here a private endpoint subnet where we can place private endpoints. And we also can set up that it's statically or it's dynamically up to you. Yeah, there are different advantages and different disadvantages using dynamic or static IP addresses. Normally, I would use static, but let's keep it dynamic because we will see it we have to figure out the DNS stuff on the next section, so we can resolve the name quite easily. It's not an issue. Okay, what we have to create is now make it a little bit bigger. We have this private link file.core.windows.net. Okay, we need a DNS zone. Why we need a DNS zone? Go to the. So the goal is to resolve this kind of IP address range, yeah, because I mean we have this blob core file windows.net in this example, yeah, but blob core file windows.net normally points to a public internet address, yeah, but now we need to make sure that we do not want to use this one, but we want to use private link, and private link is an indicator that we have a private link in place and a private endpoint. So to make sure we address the private endpoint and not the public endpoint of Azure. So that's the reasons why I say, okay, the storage account name .privatelink.blob.core.windows.net points to the 10.100.4.4, which is then the network interface card we have in place. And for that, we need a DNS record. Yeah. So the goal is to resolve the private endpoint IP address to the full qualified domain name. So Azure Service have already DNS configuration for public endpoint, and this configuration, as I said, must be overwritten. This right here. That's the reason why we need a CNAME. And we come to that also to later on and see how it works. But let's configure it in the Azure portal. Let's go to the text next. And let's create, the demo god is with us. Now it's creating a private endpoint. So when we create a private endpoint, we can also see it here in this private link section. So all the private endpoints are listed here. We can find it again. So while the deployment is running, you can have a look at the private endpoints if they're already there. Yeah, you see the network interface card, PE meetup is pointing or is connected to this kind of storage account, and it's supporting fast storage. Yeah. So we don't have a private IP address yet because I think the deployment is still running. And what we can see also is this kind of DNS configuration. Yeah. And the DNS configuration, we have this file core windows.net pointing to the 10.6.2012. It's still running, so the records are not there yet. And we can also see what I told you before is we have this private DNS zone. And in the private DNS zone, normally still deploying too fast. And normally also this DNS zone will come up, which contains our CNAME record. Let's give it a little bit of time. So what we did now is we placed some kind of private endpoint in here with the IP address, and it's a read-only network interface card, which is connected to the storage account. Please keep in mind, when you configured a private endpoint on the networking section here, please make sure that you have it disabled. If you have it enabled, you're as far as before, because then again you have the problem that public access from the public internet is still possible. That's the reason why I disable it here. Make sure that no one is getting access from the public internet. So only use private endpoints. We can save that. So now we are more or less private endpoint only, and this is the private endpoint we currently have on our subnet now. It's part of our subnet, just in here. And what we have to do is we get here for example, we had this a name record, and what we have now is we have a private link record. In our case, blob, but it could also be file, doesn't matter, or queue or table. Private link file core windows.net, which overrides then or gives you back the right IP address. And this is the IP address of the network interface. Yeah. So what is the advantage of this kind of URL? You don't have to change your connection URL. It's still the same. The records are there and it's used by DNS. So when resolving to a DNS service, the DNS server will resolve your private endpoint. Your private endpoint means you will get back the private IP address from your network interface card. So pretty straightforward. For example, this is the process. If we have a client here, like we have it here, or we have it here, doesn't matter where. It can be on premise, it can be in Azure, doesn't matter. It says, okay, give me the Azure SQL, for example, database windows.net or the file core windows.net storage account. Doesn't matter what kind of service it is. So it will ask the DNS server. The DNS server in Azure will say, I don't know the answer, but I know someone who could know the answer. So this traffic then will be forwarded to the Azure DNS. And the Azure DNS recursive resolver will say, I don't know the answer, but I know I have a private DNS zone with private link database windows.net. Probably there's a record in here which can give you the answer. So the traffic will be forwarded to the private link data or to the private DNS zone, which is linked to your virtual network and says, yes, I'm here. I'm the 10505 in this example, which is this kind of database and this the kind of network interface. So it goes back to this DNS, goes back to the DNS forwarder, goes to your client machine, and then the client machine can contact, that's number 5, your private link, yeah, or your data. In this case, then private link, and then also the database. Yeah. So DNS, to have the right DNS in place is really essential if you want to use private endpoints, because quite often I saw at customers it's a DNS mess, and then you have naming resolving issues and it's not working and so on. That's really not fun. That's the reason why I say, hey, if you want to use private endpoints, please also make sure that you have the right or you have DNS resolution in place. But normally your infrastructure team can help you, yeah, if you want to use that. So don't leave it open like this here. If we've enabled from Azure from all networks, it makes sense to configure private endpoints or at least service endpoints to make sure that your service is secure and not accessible from the internet. Before we come to the takeaways, let's switch to some general issues or additional services, because I saw that already in also some project. Because the first one was the first issue was key management. I saw it quite often that that the for example storage account has a section here, encryption, and it's always either Microsoft managed or managed by Microsoft, managed keys by Microsoft. So what does that mean? The data are encrypted by a key managed by Microsoft, but quite often the enterprise itself has a compliance rule that says the owner of the key must be the enterprise, not Microsoft. That's the reason why I said, hey, if you use, for example, a storage account or a database, doesn't matter, please consider, does the data needs to be encrypted at rest? Yeah. So for example, it makes sense if you use platform managed keys. Platform managed keys mean I'm the owner of the key. Yeah. So that also can say, okay, you can use a hardware security module, but it's a totally different story. Make sure your data are encrypted in a proper way. So you can, for example, select customer managed keys, select the key vault, select then a key from a key vault. You can also use managed ASM to get a key, and then select the key vault and also the key. So I have an RSA key with I think 2048 encrypted, and say, yeah, please encrypt my data in the storage account, and click select and hit save. Hopefully I gave the identity access to also read the key. So now the data is, you see, it's encrypted using always the latest key in the key vault. Yeah. Please normally do not use the Microsoft managed keys quite often. I saw that quite often. I mean, we talk about encrypted disks, we talk about encrypted storage account, we talk about encrypted databases. Yeah. Do that please before you're going to start, how the data needs to be encrypted, because later in the can also be a pain to change it, especially if you use infrastructure as code. Make sure it goes the right way. Yeah.
Sorry, I have a question.
Yes.
So platform managed key means Microsoft has the key, right? Or
yes.
Yeah.
Yes,
Okay. Okay, because I think you said that platform managed key, that I have the key, so I thought that you meant the company has the key. But
yeah, platform managed keys. Yes, is Microsoft managed keys. It's more or less a synonym.
And is it kind of like a default setting that people don't know about and they use it,
yes.
although the company has other? Okay, Okay, thank you. Yes, that's a
quite
good
often the
point.
guys, they do clicky, 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 for example, and then they said, okay, we use the default values, and then you have here Microsoft managed keys and next, and then you use Microsoft managed keys. Yeah, you can also use, for example, an Azure policy to verify, okay, custom managed keys need to be used. This option is not allowed. What you also can do as a background information, you can also, if you have a hardware security module in place on the on-premise side, you are able to synchronize or bring your hardware security keys to the Azure key vault and then use it for encryption. Because then you are really the, I would say, king of your key. And have full control over your keys even on the update cycle. Yeah.
Okay.
That means that's quite often important. Yeah. So bring your own key scenarios, as I said, with is also supported. Yeah. And recommendation: use custom managed keys to protect your data. So this example here is the default, but quite often you need to, according to security guidelines, you have to use custom managed keys. So now the last thing before we do the wrap up. I had some developers we say, hey, we have to we have to store our service principal credentials in the key vault, and then so to make sure that the service principal gets access then to the database and so on. I said, why you're not using a managed identity? So managed identities are on Azure quite simple because they have no password. Yeah. For example, you can add here managed identities. I added already one. We can add another one. Let's grab the name real quick. Easy to create. So it's, as you see, you don't need much to enter or to add or create a customer a user signed identity. For example, 02. Let's do review and create. Done. So what is a user or managed identity? Yeah, as you see a managed identity, it will appear here in the managed identities section after a while, and it doesn't have a password. So how does that work? Managed identities are also part of the Azure Active Directory. Come on, create it. I'm not patient. Now it's there. So we have now the 02 managed identity. And it's easy to give them now access. Yeah. So we want to eliminate the need of managing credentials because a managed identity doesn't have a password. Yeah. Right. We want to provide automatically an identity from the Microsoft Entra or Azure AD applications by default. I can show you how you can get access or how you can give permissions to the managed identity. And it's used when connecting to resources support Microsoft Entra authentication. So, and there's no need to manage the credentials. So for example, if we use our storage account and we want to make sure, okay, our application runs in the context of the managed identity. Now I want to give the managed identity access to my storage account. So I go to the access control section, say, okay, I want to assign a role. Let's give them something with data reader or data contributor, privileged contributor. Yeah, allows read, write, and delete in this file share. That's making sense. Let's grab this one. And now we say, okay, I don't want to give the access to the user, but to a managed identity. Yeah. And now we can select the managed identity. Said, okay, we have two managed identities. Let's take the 02. Click select, and then go to next, and review and assign. So now it's giving the user or the managed identity access to our storage account. Same behavior would be if you, for example, give the managed identity access to a database or Azure SQL database. Yeah, working with managed identities makes it quite easy, especially if your application runs in the context of a managed identity. You can give them access to a key vault, to a web application, to Azure Web App, whatever. Yeah. You name it. And we have two types: system-assigned identity for the lazy ones, or you really create what we did, a user-assigned identity, because also some Azure resources allow to enable the managed identity directly off the resource. But if you're doing infrastructure as code, think about how many managed identities you need. Do I only need one, or do I have to separate it for dev, test, prod, of course? So to make sure that the managed identity only have access to a certain kind of environment, but not to everything, right? So that makes life quite easy. All right, let's have a look at the takeaways. Yeah, what are the essentials? So first of all, as mentioned, check the Azure with the Azure infrastructure team before you start. There are so many things you have to think of before you start. Like, for example, you can ask the Azure infrastructure, do you have a governance concept? Or do you have a governance team? How is the naming convention? Which compliance rules we need to be applied? Yeah? Or to make sure that your application you want to program or you want to provide also meets your security requirements. Yeah? Quite often, you do not start on a green field. As you see here in this kind of chart, there's already a landing zone in place quite often. And you have to make sure that your application also fits into the landing zone to make sure you have proper access, you have the right ports in place, the network security groups are configured, the routing is correct, the peering is set up, and so on. Yeah. So check out with your infrastructure team and make sure you ask them the right question, and then they give you the right information before you start. To start making a plan, doing a network design. I like this kind of drawings. So before I put my stuff in or start clicking in the portal, or before I put my stuff bring it into code, like I like to use Terraform. Before I bring this into code, I want to have a rough plan, how big my virtual network must be, how many subnets do I need, and how do I have to separate, for example, dev test from prod environment using different virtual networks, or for example, or using different subnets. Both strategies are possible, but before you start programming or think about the structure and the architecture to make sure you have the right services and also the right network setup, because otherwise you have to do probably later on then a reverse engineering, because I saw quite often users packing everything into one subnet, the database endpoints, the web, the back end, the front end. So it's make sure you have a structure in place. So don't click, only use your like a design tool, like for example Draw or something else before you start. Think about the size of your application. How many hosts do I need? How many subnets do I need? Yeah. Is this a quite big application? You need more hosts. If you only do a proof of concept, probably you don't need that much, that many hosts, and also you can size your subnets more without any issues. That's not a problem. And also have a look on the restrictions from Microsoft, because for some services, Microsoft will tell you, hey, if you want to use the service and to make sure that it scales correctly, for example, you need at least a /26 subnet. Yeah, that could also be the case. You will find it. It depends on the service you want to use, but you will find it on the Microsoft docs. Yeah. Think about suitable separation of your Azure application workloads. That means don't put all eggs into one basket. Yeah, think about, okay, probably we need a subnet for database or for storage. Probably need to read something for the backend. We need probably some one or subnet for the front end. So how do you separate it? Think about the architecture. Yeah, especially also from a network perspective. What we had is how traffic is controlled. The Azure infrastructure team normally will also tell you how traffic will be controlled. Like, do we use network security groups, or does the Azure infrastructure team has a Azure firewall in place where we have to set up the rules, or is there another NVA, so network virtual appliance, in place which needs to be configured, like Barracuda or FortiGate or whatever? And also are there areas of shared responsibilities with other teams? Yeah. Like for example, DNS quite often said, yeah, one team managed then the DNS because could be a shared responsibility. Or for example, I have a little bit kind of a strange guts feeling if everyone is able to adjust rule settings here on the Azure firewall, because then after a few weeks you have here the Wild West, which doesn't make sense. So it makes sense to have this kinds of rules set up within a 4-eyes principle. So from a application perspective, you make recommendation, and the infrastructure team will have a look over it and will say, yeah, this is fine, we can implement it, or say, oh, we have to change it somewhere over here. So you are, I would say, not alone, and quite often an infrastructure guy and also a governance guy should be part of your application team. Yeah. And secure your Azure services using the network section as illustrated on an Azure storage account, using service endpoints, using private endpoints. Find the right setup for your services. Make sure that they are not available on the public internet so everyone can access it theoretically. It makes sense to secure it before an incident happens. So quick wrap up about myself. Yeah, I'm a cloud solution architect at Xperiot. We are part of the Xivia group. I'm a Microsoft MVP in the field of Azure infrastructure as code. I stick to Terraform. That's what my passionate customer project is at the moment. Yeah, so yeah, I'm coming more from the identity and access management field, and went more and more into the Azure infrastructure and governance part over the last few years. Did quite a lot of Azure reviews as well at customers, helped customers bringing workloads successfully to the cloud. I'm a big fan of infrastructure as code. Try to avoid click ops. Don't click in the Azure portal like I did today. It's really not recommended using infrastructure as code to really set up your environment from a fully automated with an end-to-end automation is really essential. I've never seen a customer who was successful or had a successful cloud journey doing clickety-click in the Azure portal, because it's in my opinion, it's not manageable and it's not consistent. Yeah. So that's more or less it from my side. If you have questions now, it's time to ask. So unmute your microphone. It's a pleasure. It would be a pleasure to answer the questions. So let me know. If you have some issues or know something, want to know something.
Stefan was great. There are a few questions in regard to share your content, please. Would say
yes.
This recording I will manage to make it public in the next days on YouTube. So I will share this link so you can just publicly get this video. The slides you already said you share the slides and get in your GitHub repository, so easily accessible. So everyone that is interested in the slides can go to the GitHub, and yeah, the GitHub handle of Stefan is rapstar83. So keep this in mind or write it down or whatever, or we can type it here. Rapstar83. So it's a GitHub handle. So in that case, you can grab whatever you like. But anyway, if you have some questions, maybe not directly tied to what Stefan said. So he is an expert. He is for sure willing to answer any question in regard to Azure and infrastructure. So as long as it is not code, it is, I think, a pleasure for him to answer. Otherwise, it was great to have you here. Questions? If not, and I stop recording.
Too much content.